Let's say question number 25. Now the question you see here belongs to section of heat and thermodynamics. A massless spring of spring constant 800 Newton per meter was attached with a mass of 500 gram and the system is completely immersed in 1 kg of water. The spring is stretched by 2 centimeter and released so that it starts vibrating. So some energy was provided to it, right? And what would be the order of magnitude of change in temperature of water when the vibration stops completely? And what is given to us is the specific heat of the mass, that is 400 joule per kg per Kelvin, and the specific heat of water. Now in that case, the energy which was stored in the spring will be released and that energy will be utilized to increase the temperature of two things. One is 1 kg water and second is the mass of 500 grams. So energy stored in spring is half kx square. That would be equal to the change in energy for mass, that is equals to 1 by 2 into 400 into delta T, that is the change of temperature of the mass, plus 1 kg into 4184 into delta T. This is the change in temperature for the energy which is resulting in change in temperature of water. So from here when you solve, this is half into 800 into 2 into 10 to power minus 2 whole square. So when you solve this, you will get this as half into 800 into 4 into 10 to power minus 4. So this would be twice and this will solve to be 16 into 10 to power minus 2 joules. Now this energy is utilized for two purposes. So when you solve here, you will get 200 delta T plus 4184 delta T. So calculating the value of delta T from this given equation, you will get delta T equal to near about 10 to power minus 5 Kelvin. Let's see which is the best suited option here. So among the four options given to us, yes, option 1 would be the right answer to this question. Now let's move on to our next question, that is question number 26. Now the question you see belongs to section of mechanics. Here a particle of mass m is moving with speed 2v and collides with a mass 2m moving with speed v in same direction. After collision, the first mass is stopped completely while the second one splits into two particles each of mass m, which moves at an angle of 45 degrees with the original direction. We have to find the speed of each of the moving particles in this case. So let's see. So as per the given diagram, I have made one for you. You can find that this was mass m, this is mass 2m, it was moving with speed 2v and this was moving with speed v. So initial momentum before collision was 4mv, right? After collision, this mass totally stopped, so there will be no momentum of the same. This mass was dispersed into two bodies, that is m and m, at an angle of 45 degree as per the question, right? So their initial velocities was something else. Now in this case, let's take the velocities as v1, right? So when you take the components, you will find that 2m v1 cos 45 will remain here and the sine components of these two will be cancelled. So this is the final momentum which is remaining. This is the initial momentum and they should be equal in magnitude as no forces acted on the system. So P initial should be equal to P final. This is 4mv which is equals to 2m v1 cos 45, so 1 by root 2. On solving this, you will get v1 as equals to 2 root 2v. Let's see which is the best suited option here. So among the four options given to us, option number 4 is the right answer to this question. Hope you have understood this one. Now let's move on to our next question. Now the question you see here belongs to section of oscillation and waves. A string of 2 meter long and fixed at its end is driven by 240 Hz vibrator. The string vibrates in its third harmonic mode. The speed of the wave and its fundamental frequency is. So in order to solve this question, you need to know what is the frequency of third harmonic. So F will be here, that is 3V by 2L, right? Now that frequency is given as 240 hertz. What is the length given? That is 2. So let's put down the values. So when you put here 3V divided by 2 into 2, that is equals to 240. You will get V as 320 meter per second. This is the velocity. Now, what next is asked? That is the fundamental frequency. So this is the third harmonic. Fundamental frequency would be F by 3. That is equals to 80 hertz. Right? Let's see which are the best suited option among these. So option number 2 would be the right answer to this question. Now it's time to move on to our next question, that is question number 28.